These are our pre-calculus notes for 6-4 partial fractions. So we've spent a lot of time working with fractions like this and adding them together. And the way we add them together is by coming up with a common denominator. So I'd have to multiply my first fraction by an x plus 4 over x plus 4, my second fraction by x minus 5 over x minus 5. And what I'd end up with is 2 times the quantity x plus 4 plus negative 1 times the x minus 5 all over that common denominator. And then we would go through and we would distribute the 2 and the negative 1. And then we'd put our like terms together. And we would combine our fractions and we would just get, let's see, an x plus 13, which is what I warned you the answer was going to be in the first place. So today we're looking at working backwards. So partial fractions is going to be this process where I take something like this and I break it apart into this. These are my partial fractions up at the top. Partial fractions. Let me refocus this really quick. So I am taking some kind of a rational expression, and instead of putting my fractions together, I am taking them apart. And this is called partial fraction decomposition. So there are some rules for partial fraction decomposition for how we break them apart. And what I want to go through and do is to show you like one rule at a time and then an example for how that rule works. So that's where we're going to be doing our notes today. So my first example is, let's go ahead and flip the page here. Oh, I guess it's at the bottom. We are looking at a denominator with non-repeated linear factors. So that's our first example. So let's go ahead and look at this fraction. If I factor my denominator, I have an x minus 4 and an x plus 3. And these are both linear factors and they are not repeated. The linear factors are different. So it says if I have linear factors, it means that each of those linear factors is going to have a constant in the numerator. So for constants, we're going to use stuff like A, B, C. We'll use capital letters. And so because I have an x minus 4 and an x plus 3, each of those will end up being a denominator. And I have a constant in the numerator, so I'm going to put an A with my first fraction and a B for my second, and then a plus. So I know I'm going to be breaking it apart. These are going to be my two different denominators, and they're going to have constants in the numerator because I have a linear factor. So now I've got this equation that I need to solve. So I have worked with rational equations a lot in the past. I know that I need to multiply by this denominator here, by the whole thing. Let's look at what happens when I multiply this times my first fraction. My entire denominator cancels. I'm left with x minus 25. When I multiply this times the a over x minus 4s, the x minus 4s would be gone. And I have an a times my x plus 3. And then when I multiply this times my b fraction, let's see, the x plus 3s are going to be gone. And I will have a b times x minus 4. So then I want to go through and distribute this. And I know at this point it looks like there's 3 different variables in one equation. It looks kind of scary, but we will have a way to take care of that. And then I'm going to regroup this. I have x first and then constants. So on the right-hand side, I want to put my x's next to each other. So ax and bx, they both have an x term. And then the 3a and the minus 4b do not have any x's, so they're both constants. And then I'm going to do one more kind of tricky step here that you might not see why I'm doing this. And I'm going to take my x and factor it out of these first two. So I have a quantity a plus b times x, and then plus, I'm going to write the 3a minus 4b in parentheses as well. So now what I have at this point is I have a 1x, and I have an a plus b times x on the other side. Here I have a minus 25, and here I've got a 3a minus 4b. So it turns out that we can make the 1 equal our a plus b because those are our x coefficients, and the negative 25 is going to equal the 3a minus 4b. So that's going to give us 2 equations to solve. So we're not solving for x, we're just solving for a and b. And so I have 2 equations and 2 variables. I meant to write a plus here, let's fix that. So a plus b is going to equal 1. And 3a minus 4b is going to equal a negative 25. So you will be relieved to know we're not going to go and change this into a matrix form or anything to solve it. We're just going to solve using methods we always have. So I'm going to multiply the first one by 4 so that my b's can be eliminated when I add my equations together. So let's go ahead and add, and we get 7a equals negative 21. And so if 7a equals negative 21, a equals negative 3. And then I want to solve for b, so I know that a plus b equals 1. So negative 3 plus b equals 1, so b equals 4. So my last step is actually breaking apart into those partial fractions. So I have a equals negative 3, I have b equals 4. Now I have to put it all together. So I want to actually write this part of it. I found that a was negative 3, so it's going to be negative 3 over x minus 4 plus b was equal to 4, so I have 4 over x plus 3. And if I add these two together, I would actually get that original, the x minus 25 over x squared minus x minus 12. So this is my partial fraction decomposition. I can take this fraction, this rational expression here, and I can break it into these two fractions, these two partial fractions. So that would be my answer. Ideally, this would be at the bottom. I ran out of room at the bottom of my page there. And it's easier to have this next to the A and B, so I can kind of show you where stuff comes from. But just keep in mind, we should be keeping our work vertical. So for the second one, I have an improper fraction. It's improper because they both have an x squared in the top and bottom, but I have a 2x squared on the bottom and only a 1x squared on the bottom. So don't worry about that negative sign when we're thinking about improper. So that means my first step is to use long division, so it's not improper. So I want to write out my numerator, and I am going to divide by my denominator. And let's see, x squared divides into negative 2x squared, negative 2 times. And then we multiply it back. And then remember, we're subtracting all of this. So that means I really have negative 2x squared plus 2x squared, which is a 0. And I have a 9x minus a 2x. So that is going to be a 7x. And then I bring down the minus 4. So right now I can't divide x squared into 7x, so I am done. My answer would be negative 2 plus 7x minus 4 over the x squared minus x. And this is actually the part that I want to break apart. So I am going to go ahead and factor that denominator. So because the negative 2 is already done, I already have that plus my fraction, I'm going to just kind of ignore that for now, and I'm going to work on this part. So I'm going to break this apart. So we're going to use our partial fraction decomposition here on this part. So I'm going to kind of ignore the 2 for now. So if I have 7x minus 4, x is a linear factor, x minus 1 is a linear factor. So I want to make this 7x minus 4 over x times x minus 1 equals a over x plus b over x minus 1. And then we're going to multiply again by this whole x times x minus 1 by like our least common denominator to cancel everything out. And we say cancel very loosely because that's not really the right word, but it's kind of the slang we all use. We go ahead and multiply this. When I multiply this times my first fraction, I get just a 7x minus 4. When I multiply this times my a over x, my x's are gone. I have an a times an x minus 1. When I multiply this times b over x minus 1, my x minus 1s are gone, and I have a bx. So then I want to go ahead on the right and distribute and put my x's together. So from here, it's just pretty much straight algebra. So I have an a plus b times x. And then I want to look at what's equal again. So my 7 is my x coefficient. So 7 is going to equal the a plus b. And my negative 4 is going to equal my negative a. So I can get a right away. If negative 4 equals negative a, I'm going to go ahead and write that down. So a equals positive 4. And then I would have a plus b equals 7, except a is 4. And so b equals 3. So now I want to go ahead and write down my answer. So when I break apart that original fraction, I'm going to have a negative 2. Remember, there is this negative 2 down here. So I'm breaking apart this fraction. So that's equal to negative 2 plus, and then I'm going to have something over x. I had a here, and a was 4. So 4 over x plus, And then my second fraction was b over x minus 1, and my b is 3. And so this is how I would decompose that original fraction. So we're breaking it down into multiple fractions. The next one, the rule is a little bit harder to understand. It's when I have a repeated factor. So if I have a quantity ax plus b in my denominator to the nth power, it says that linear factor is repeated n times. So let me give you a quick example of that. So if I had something over, let's come up with a linear factor, let's say like 3x plus 7, and that was to the 4th power, then what that would mean is first I would have that a constant over the 3x plus 7. Then I would have a constant, a different constant over the 3x plus 7 squared. And then I would have another constant over the 3x plus 7 cubed. And then my last constant would be over the 3x plus 7 to the 4th. So it's repeated 4 times, and the power goes up as 1, 2, 3, 4. So that's the part that I think is kind of hard to word here in this rule. It's hard to understand. So now we're going to look at an example of that rule. So I want to take my denominator, and let's see, I could factor out an x first. And then, oh, lo and behold, I have a repeated linear factor. This is an x minus 2 squared. So what that means, and I'm going to start this problem maybe over here, plus 4. This is just going to be like my scratch work here. So my first linear factor is an x. That one's not repeated. So I'm going to have an a over x. But then this x minus 2, that factor is repeated. So first I'm going to have a b over x minus 2. And then I'm going to have a c over that quantity x minus 2 squared. So because this is squared, because it is a repeated linear factor, first I have it to the 1st power and then the 2nd power. So I would multiply this whole thing by the x times x minus 2 squared. So when I multiply it over here, we'll just have that numerator. When I multiply it by the a over x, the x's are gone. So it'll be a times the quantity x minus 2 squared. Let's see, this middle one, I am taking away just one of my factors of x minus 2. So we'll have a bx times an x minus 2 still. And then here the x minus 2's are gone, and we'll just have a cx. So now I want to go through and do all my distributing and expand my binomial, and my left-hand side is just staying the same. So we'll have, let's see, ax squared minus, the middle term would be doubled, minus 4ax plus 4a plus bx squared minus 2bx plus cx. And then we want to go through and kind of group our terms again. So we want x squared and then x and then a number. So let's put our ax squared and our bx squared together. And then we have a minus 4ax, a minus 2bx, and a plus cx. And then at the end, our only constant term is the 4a. And it looks like I have all my terms accounted for because I had 3 up here or 6 up here, and I still have the 6. So now I'm going to go through and do that kind of factoring step, which is maybe not super necessary, but very helpful. And I'm going to make this a plus negative. All right, and then after I do that, I'm ready to go through and write my equations. So it looks like a I'll be able to get right away. I have a constant that's 4, and here I have a 4a. So if 4a equals 4, then a equals 1. And then if I look at my x squareds, I have a plus b has to equal 3. So then I'll put in my 1 for a. 1 plus b equals 3, so b equals 2. And then last, I'm going to have to find c. So negative 4a minus 2b plus c equals my coefficient of x. So the negative 5, because this is all my coefficient on x. So that's going to be equal to the negative 5. And then I want to substitute my values for a and b that I already found. I already know that a is 1 and b is 2. So negative 4 times 1 minus 2 times 2. That's a negative 4 minus 4 plus c. So negative 8 plus c So c is going to be equal to 3. So now my last step is to go through and split this fraction apart. So I know if I have 3x squared minus 5x plus 4 over the x times x minus 2 squared, that's going to equal first a over x. So a over x, my a I found was 1. So 1 over x plus, let's see, b over x minus 2, and my b was 2. So 2 over x minus 2 plus my c over x minus 2 squared, and c is 3. So this is how I would decompose or break apart that fraction into multiple fractions. So we do have one last example. So we've looked at only linear denominators or factors of linear denominators so far. And next we're going to look at what happens when I have a quadratic factor in my denominator. So this one is on its own page, which makes it look a little bit scarier, but the work is not any longer than the last one. So when I want to break this apart, what I notice is I have a quadratic factor and it's squared, so it's also repeated. So repeated means I'd have this thing to the first power and then this thing squared. So let's do that part of it. And then what do quadratic factors mean? Quadratic factors mean linear numerators. So linear would be like mx plus b, except instead of m and b, we're going to use our capital letters like we've been doing. So the first one's going to be an ax plus b, and the second one is going to be a cx plus d. So now we're going to solve like we have been. We're going to multiply by that denominator. And let's see, when we multiply this by the first fraction, we just get the x cubed, minus x. When we multiply here, we're canceling out one of our factors of x squared minus 3. So we have an ax plus b times x squared minus 3 plus. Over here, we would cancel our entire denominator again. And we have just a cx plus d. So I know that these two are the same. It might not look like we're breaking it down, but our numerator is becoming a lot more simple. Instead of having a cubic numerator, we're going to have only linear numerators for both of our fractions. So it really is going to be more simple. I don't really need parentheses here, but it might help see kind of what's going on. So on the right-hand side, I have some distributing to do. And then I want to group again. And it might help in this step if I'm thinking about how there's 1x cubed, and there are 0x squared, and there's minus 1x, and there's no constants. So I'm kind of thinking about this and then like splitting that apart so I can look at all those different terms. Because I have x squareds over here, I have constants over here. And then it looks like my cubed and my squared stuff is already all set, but I have my 3ax and my cx. So I'm going to write negative 3a plus c times x, and then I have a plus negative 3b plus d. So I'm working this one out maybe a little bit faster. So when I go left to right, I see that I have a 1x cubed and an ax cubed. So a equals 1. I have a 0x squared and a bx squared, so b equals 0. So now I'm going to look through at my x term. So x has negative 3a plus c. And my x term over here is a negative 1, so equals negative 1. And I already know that a is 1, so negative 3 times 1. So let's see, c equals 2. And then I want to find d. So this is my constant term. This is my constant term. So negative 3b plus d equals 0. And b is 0. So this is 0, so d is just equal to 0. So then I want to take these fractions, and I'm going to go ahead and decompose and kind of build up my numerators. So I'm going to move this out a little bit for the last step. So this is the fraction I'm trying to break down, and my first numerator is ax plus b. So a is 1 and b is 0. That's a 1x plus 0 over that x squared minus 3. And then I have a plus. Cx plus d would be 2x plus 0 over the x squared minus 3 cubed, or sorry, squared. So I'm getting this from this right here. I'm just filling in numbers for a, b, c, and d. And I know that this is not simplified, but I find that doing that all in one step, especially the first day we learn this, is really confusing. So I'm going to take an extra step. And I know I don't need to write down the plus 0. I don't need to write down the 1. So this is just an x over x squared minus 3. And here I have a 2x over the quantity x squared minus 3 squared. So that is going to be my partial fraction decomposition. So partial fraction decomposition is a process that we follow. So we're taking some kind of rational expression and we're breaking it apart into these multiple fractions, following rules for whether there's linear factors or quadratic factors, and whether or not they're repeated, and then solving for these letters for A, B, C, and D. We're using different constants there and solving. So please be ready to ask questions in class.